Welcome to yet another addition to our Python playlist by Simplilearn. I'm Anjali and today we'll be covering all the basic concepts of Python followed by some of the libraries which are very essential when you learn Python. So we'll start right from printing your Hello World, which is the most basic program whenever you learn a programming language, up to even implementing one of the machine learning algorithms through simple code and utilizing a Python library to do so. So this tutorial starts from the very basic, even if you're completely new to Python and have a basic understanding of any other programming language, this should be quite helpful for you. So let's begin. Now, as I mentioned previously, our first program would be to print out Hello World like we always do. Now in Python, whenever you want to print out a string, a number or anything as such, you use this print function. It's very much similar to printf or cout, whichever language you prefer to use. So you just say print, open brackets, and since it's a string, I put them within double quotes, and in here just type out hello world and just run this line, and as you see here, hello world is printed out. Now another very cool thing that you can do with Python is you can print a string out any number of times without actually having to repeat it. So if I want to print out hello world 10 times, I do not need to type it 10 times, rather I can just do this. So just like before, put in hello world within double quotes, and then you just say into 10. Now when you say this, as you can see here, hello world has been printed out 10 times. Now of course this is not done right because world and hello are put in together. So just put double spaces after world, run this again, and as you can see, hello world is printed out 10 times. Now obviously when you're programming, this kind of a thing doesn't really come in use, but it's nice to know that you can do something of this sort. Now the next thing we'll be covering here is variables. So variables, as you probably already know, is a box which basically stores a value. Now this variable can store an integer type of value, it can store a string, a float, or any other type. And Python is dynamically typed. So what this means is, unlike in Java or any other programming language where you have to actually mention the type of value that the variable holds at the time of creation of the variable, in Python you do not need to do that. So you can just have any variable, say message, don't specify its type, just assign it a value. So over here I'm going to assign my variable the value hello world. Now when you say this and run your code, Python automatically understands that this value is a string and that is what is being assigned to this variable. So now to print out the value of the variable, you just say print and put in the variable name. So guys, please notice here that initially when we had to print out a string, we put them in double quotes. Here we are not putting the variable name in double quotes. So this is because we do not need to print out the variable name. If I put out message in double quotes, it'll literally print out message. But what I want to print out is the value that is stored in message. So want to print out the value of a variable, just put in the variable name without any quotes. Now I'll run this program, and as you see, hello world is printed over here, which is the value stored in our variable. So that is a basic on how variables work. We'll explore this further as we cover other concepts. So in our second program, we'll be creating a very basic calculator which will perform addition, subtraction, multiplication, division, and find the remainder. So here first we'll look into how numbers work in Python. So just like any other programming language, or in fact just like in math, numbers basically can be integers or it can be floating point numbers. So integers are whole numbers like 1, 2, 3, 4. And floating point numbers are the ones with digits after your decimal point. So that's 2.38 and 5.63 and so on. So here what we'll do is we'll first take in two values from the user, store them into a variable, and then perform different operations on these values. Again, the operation performed on the value will also be a choice which will be given by the user. So let's begin coding. So let's take in our first value from the user, and to take in input from the user, Python uses a function called input. Now within this function, you can pass a message which will be displayed to the user, basically instructing the user as in what he or she has to input. So we want the first digit for our operation. So we say enter the first number, and that now input function returns the value which is given by the user. So that will be stored in our variable A. Now we need another number from the user which will be our second number. So I'll just copy paste this line here and change first to second, and this time my variable will be b. So my first input will be stored in the variable a, second input in the variable b. Now one more thing we need to consider. So in Python, every time the user gives an input and the input function returns the value, it returns it as a string. So everything the user inputs is basically a string. But what we need in our variables a and b are integer values. Now this is very important because we are going to perform operations on these. So we need to convert the value returned by the input function into int, and this is how you do it. So you just say int and within brackets you pass the input function. So now your string gets converted to an int. Now if you want to convert the string to float values, it's exactly the same thing. Just instead of int, put their float. So now you have a and b, both are integer numbers. Now the third input that you need from the user is what operation the user wishes to perform on these values. So it can be addition, subtraction, multiplication, division, or finding the remainder. So let's give this message to the user. So in here, I say enter 1 for addition, and the /n is basically skipping to a new line. So on the second line, I'll have enter 2, subtraction, enter 3, multiplication, enter 4, division, and then enter 5, find the remainder. So those are the three inputs that we need from the user: our first number, our second number, and the operation that needs to be performed. Now once again, this value entered by the user, the option, again we'll be converting this to an integer. Now in this particular case, it's actually not necessary to convert the option to an integer because you're not going to perform any operations on it. We can simply do the comparisons considering this to be a string, but we'll still convert it to integer because that is essentially what we mean here. I mean, we are taking the input as one of the numbers, so why not have it stored as a number? And that would be stored in my variable choice. So now here we'll introduce another new concept, which is the if-else-if ladder. So what is this ladder? Well, so quite often in programming, we need to make comparisons to take a particular path. So suppose I have a variable a and it stores some value, some integer value. Now I'll say if a is less than 10, do this. If a is greater than 10, then there's a whole different set of instructions that you need to perform. So to decide which path to take, that is when we use if or else if. So if I say if a greater than 10, perform this, and if a is not greater than 10, that is what comes in else. So if a is greater than 10, perform this, else, that is if a is not greater than 10, then perform this separate set of functions. So I'll start typing this out. We'll notice the syntax here and how exactly this works, and things will be much more clear to you. So I start my if statement. So I say if choice is equal to 1. So if what integer, the value stored in choice, is equal to 1, then we'll perform the statements under this block. Now once again guys, over here we are using two equal to signs, while here we are using just a single equal to. So the single equal to sign indicates assignment operator, that is this value here on the right hand side of equal to is assigned to the variable on the left hand side. But then again, when you have two equal to signs, that is a comparison operator. So it compares if the values on its left and right are equal, and it returns a boolean result. So it returns either true or false. Now if this expression here returns true, then we enter the if block, and over here we'll place the instructions to be executed if this statement does result to true. So if choice is equal to 1, that means the user wants to perform addition. So if the user wants to perform addition, I'll have a variable here, say result, and result will be equal to a plus b. So this is exactly how you do math or how you perform this operation in any other programming language. You have a variable to store the result. In our case, it's even named result, and the additions performed by operator 1 plus operator 2. We use a single equal to, which is the assignment operator. So if choice is 1, then you perform the addition, store the value in result. Now if choice is 2, so if choice equal to 2, then what do we do? Now before I proceed with this, I purposely made a mistake here just so I can explain this concept to you better, which is, so when I put an if statement here, what happens is that the first if statement's condition is checked, and then irrespective of whether this is true or false, it'll still check a second if condition. But this is not what we want, because see, if choice is 1, obviously choice cannot be equal to 2 or any other number as such. So here, instead of saying if, we we say elif. So elif is basically a short for else if this is true. So if choice equal to 1, do this. Else if choice is equal to 2, do whatever we put in this block. So when we put else if or elif instead of if, what happens is that if your first if condition results in true, it'll skip all the other elif statements that you'll have along with this if statement. So again, you can have n number of elif statements. So let's look into that. First, we'll put in our result value for the choice equal to 2. So that means the user wants us to subtract. So you say result equal to a minus b. Now guys, if choice is not 1, choice is not 2, then there's a possibility choice would be 3. So again, we can have another elif here, and this time we check if choice is equal to 3. Now if that is true, we do a into b because that's multiplication. And if that is also not true, choice must be equal to 4, in which case we do a by b. And if choice is not even equal to 4, it might be equal to 5, in which case result will be equal to a mod 5. So the mod operator basically returns the remainder of the division. So it does a by b, and whatever is the remainder from this division, it returns that value, and that'll be stored in result. Now see, if choice is neither 1, nor 2, nor 3, 4 or 5, that means the user has entered some number that was not a part of the option. Now we do not know what this number is, but we know for sure that this value or this choice is invalid. So in that case, we say if none of these statements resulted in true, then we can have a else statement where we say result is equal to invalid choice. So once again, let's recap till here. We take two inputs from the user. We take a choice from the user, which could be any number between 1 and 5. And we have the if elif ladder here to branch out based on the choice the user has given. So if it's choice 1, you store the sum of a and b in result. Choice 2, the difference of a and b. Choice 3, the product. Choice 4, a by b. Choice 5, the remainder of the division. And if it's none of these, you store invalid choice in result. So since Python supports dynamic assignment, we do not need to restrict our variable value to be integer or float. It can be anything so far. All these values are integers or floats, and this particular value here is string, and it's completely fine. This works well with Python. Now out here, what we do is we'll just print out the result. So depending upon the choice the user has given, that particular value will be stored in result, and the result will be printed out here. And again, if the user gave an invalid choice, that's exactly what will be printed out here. Now the thing with else if ladder and why we did not put if and instead we went with an if else if ladder is because now if this resulted in true, the execution will be interrupted here and will go to this print statement. So it'll skip all these elif statements because the system now knows that the structure of this elif statement is such that only one of them can result in true. The minute that one statement or the one expression results in true, it skips outside of these statements. So now let's run this code. So you give your input. My first number is 20 and 10. Then you have a space here to give your option, and I'll choose multiplication, and it gives the result. So 20 to 10 is 200. Now you can run this multiple times, select the different options to see how that works. And so that is our basic calculator program. So here we saw a better use case of variables. That is, variables hold a value and it can be used multiple times. So irrespective of what the value of a and b is, you do not need to change anything else in the code because we are not actually inputting numbers here, but the variable. So the value the variable holds just changes, but its use does not change. So that is the advantage of using variables. We also saw numbers in Python. We saw how you can input numbers or you can accept numbers from the user. Whatever the user enters is string. So basically how you can convert that into another data type. We also saw something very important, which is the if-else statement or the if-elif ladder. Why it's used, how it's used, the advantages, how it runs, and so on. So that's quite a lot of concepts covered in just one program. Now let's move on to our third program. So the next thing we'll be looking at are lists. Now list is something new to Python, and what are they? Well, basically they are a sequence of objects. So in Python, everything's an object. A string is an object. A class is also an object. Numbers are objects and so on. So you can have multiple objects stored one after another, and that is what lists do. Now in lists, the order of the objects is very important. Not to say that 2 must come after 1, but if you are storing 2 after 1, then that is how it will remain. So the order in which you form the list is exactly how it's stored. Lists are also mutable, as in you can change the objects in a list. You can remove objects from a list. You can add other objects to the list even later on after the list is created, and elements of a list can be accessed using indices. So let's begin. First, we look at how to create a list. So again, a list will be stored in a variable. So my variable name is lst here, and to create a list, all you need are these square brackets. Now within these square brackets, you put in all your objects. So as I mentioned earlier, a list does not pertain to a particular type of object. You can have strings, numbers, floats, everything stored together. So here our list would have 1, 2, 3, 4, 5 and the string Simplilearn stored. So all the elements of a list are separated by commas, and this is a very simple syntax to create a list. That's how it's done. Now we'll print this list out, and you can see all the elements of the list here are printed. Now, as I mentioned earlier, to access individual element of a list, to access the individual elements of a list, you will be using indices. So how do indices work in a list? Well, every sequence in Python as such has its index starting with 0. So our number 1 here is stored at index 0, number 2 at index 1, 3 at 2, 4 at 3, 5 at 4, and the word Simplilearn is stored at the index 5. So basically the length of your string here is 6, but the last index of your list would be 5 because the indices start from 0. Now if I want to access the first element of the list, I just say list, and within square brackets pass 0, which is our first subscript. So you get 1, which is the first element of our list. Now similarly, if I want to access, just put in print statements here. Well, in Jupyter Notebook, to print out one line, you actually don't need a print statement. But in this particular cell, we'll input multiple lines. So I'll have a print statement. Now, the next thing I'll be printing out is I want to extract the number 4 here. So how do I do that? Well, 1 is at 0th index. So 4 is at the 3rd index. So I just say print lst, and yeah, so we extracted 4. Now, suppose you want to access a particular element, but you do not know the length of the string. All you know is that this element is the last element of the string. How do you access the element then? Well, this is where negative indexing comes in handy. So with negative indexing, the order of the indices starts from the back, and this time we don't have 0, we start with 1. So Simplilearn is at index -1, 5 is at index -2, 4 at index -3, and so on. So to extract the last element, I'd say -1, and you get the string Simplilearn. Okay, now I want to find the length of the list. To find the length of the list, or actually any sequence in Python, you use the length function, and as a parameter to the length function, you pass the variable which holds your list, string, or whatever. Run this. Now the next thing we do is we will find out the length of our string, and for the length of the string or any sequence in Python, you use the len function, that's len, and as a parameter to this function, you pass the variable that holds your object or the sequence. And as you see here, you get the length. So the length of the string is 6. You have 6 elements in here. Now, as I had mentioned earlier, lists are mutable, so they can be changed. Let's see how you can mutate a list. Now, there are particular functions, inbuilt functions that are used with lists. We look into those. Now, the first one is the append function. You use the append function when you want to add an element to the end of the list. So I want to add a number, say 3, to the end of this list. So I say lst.append, run this line of code, and now I'll print out lst. As you can see here, 3 has been appended to the end of the list. Now in the similar manner, you can also remove elements from the list. lst.remove is the inbuilt function for doing so, and as a parameter you pass the element that you need to remove. So suppose I want to remove the string Simplilearn, so I just pass that in here, after which we'll print out our list, and as you can see here, Simplilearn has been removed. Now you can use a function to reverse this entire list. So lst.reverse print out LST, and as you can see here, your entire list has been reversed. Now you can also sort the list out with just one function, which is of course sort, and print out LST once again. So all your numbers have been sorted now, 1, 2, 3, and since you had 2 3s, it's been brought to the middle. So those are some of the basic inbuilt functions that you can use with lists. Now here I'll introduce another topic, which is the for loop. So if you have gone through any programming language before, you know there's this concept of loops, which is basically used to iterate or perform the same task multiple number of times. Now for loop is used for iterating over a sequence mainly. So here we say for I in LST. I'll explain the syntax to you. So LST is the sequence that we want to iterate over, and I is a variable which takes every value in turn from the first element of LST to the last element of LST. So for the first run of your for loop, I will take the value 1. For the second run of your for loop, I will take the value 2. And this incrementation also happens automatically when you're dealing with for loop. So here, what I'll do is I'll just print out the value of I so you can see how it's proceeding. So as you can see here guys, I has taken the value of 1 followed by 2, 3, 3, 4 and 5. Exactly, it's covered all the elements of our list one by one. So of course there are multiple uses of for, but this is one of the major advantages of using for loop, that's iterating over a sequence. This is true not only for lists but also strings, because strings are also actually a sequence of characters. We'll see this in a while. So that is the basic of lists. Now another thing you can do with lists is you can have nested lists. So nested lists are basically lists inside lists, which is again possible because as I told you, lists in Python are not pertain to a particular data type. So my second list would be called list2, and the elements of this list, and as elements of this list we'll have 3 other lists. So my first element of this list would be a list which contains the integers 1, 2, 3, comma, and you give your second element of list 2, which is again another list with the integers 4, 5 and 6. And my third list would be the characters or the strings ABC. Now let me print this list out. So as you can see here guys, list 2 is a list which is indicated by these outer square braces, and within that we have 3 elements. Each of the element is again a list. Now you must be wondering, like we iterated over our list LST using a for loop, is the similar thing possible with a nested list? Well, yes it is, and the key here is that for accessing every element of a nested list, you use a nested for. So basically you have a for loop inside a for loop. So you start with for I in LST2. Now what this I will be accessing is every element of LST2, and every element of LST2 is actually a list. So I will hold each of these lists. The first time I will be holding the list 1, 2, 3. The second time I will hold the list which contains elements 4, 5, 6 and so on. So once I has a list, we'll now iterate over the list that I holds rather than LST2. So you say for j in I. So now if I is holding the list which has the elements 1, 2, 3, j will iterate over this list and j will hold the elements 1, 2, 3 consecutively. So I'll print out j, and every time we are printing out the elements of the inner list, I'll put in a print statement here to skip to the next line. And here in our inner print statement, say end equal to quotes. So what this does is after printing the statement, it doesn't move on to the next line. It stays on the same line. So 1, 2, 3 should be printed on one line, and then before you print 4, 5, 6, it skips to the next line. So let's run this code now. So once you run the code, you see the results here. 1, 2, 3 has been printed in one line, 4, 5, 6 next line, and ABC on the third line. So that is how we deal with nested loops and nested lists. Now the next thing we look at are tuples. So tuples are just like lists, except for tuples are immutable. So what I mean is that like you can change lists even after it's created, tuples are not so. Once you create them, they're static. They cannot be changed at all. So other than that, pretty much everything's similar, and syntax wise there's a slight difference which we look at now. So let's start off by creating a tuple. Name my tuple TPL, and like before, when we were creating lists, we had these square braces, right? So this time for creating tuples, we have our curved braces. So that's the only difference with the syntax. Now I'll put in some elements into my tuple. Now here too, we can have any data type. So I can even have a string in here, and then I'll print out my tuple. Indexing for tuples or extracting the various elements of tuples, just like as it works in lists. So you have TPL and just given an index here, say 4, and we'll print out the object stored at the 4th index. Now see, with lists, you could manipulate them. So initially we had created a list lst. Let's run that again. These are the elements in our list lst. Now suppose I want to change this particular 3 to 6. So that would be at my index location 0, 1, 2, 3. So I could say lst3 equal to 6. And then I'll print out lst. And as you see here, you can change a list or the elements of a list as simply as that. But now I want to do the same to a tuple. So is it possible? My tuple has these elements here, 1, 2, 3, 4 and Simplilearn. I want to change the number 2 to number 10. So that is at the index location 1. So I could say TPL1 equal to 10. Following the same syntax, run this code and you see here an error has occurred. So this is what I mean by tuples being immutable. Unlike lists, lists were prone to changes. You can change them whenever you like. Tuples, you cannot do that. So the first time you create a tuple, ensure that it's exactly what you want. Now tuples are usually not used for this very reason, but it's good to know about the various data types Python offers. Now Python supports another type of data type, which is strings. Strings are basically a sequence of characters. Now if you have gone through any other programming language before, of course you must be familiar with strings because that's one common data type used in almost all languages. So let's begin. We'll start with storing a string in a variable. So my first variable name is var, and in this variable I'll store my first string. Now strings are always within double quotes. So I have my double quotes here, and within that I'll put in the word let's. Now I'll print out this variable, but I want to print out let's learn Python. So here what I'll show you is how you can concatenate strings or concatenate a string along with a string stored in a variable. So first you put in your variable name var, and I want to concatenate this to the string learn Python. So here I have inserted an extra space which should appear after the word let's, and now to concatenate them you simply use the plus symbol, and that's it. So that is your first string output. Now we can also have this other string that's learn Python stored in another variable. So I say var2, which is my second variable, and within the quotes once again type in your string, and then we'll print this out var1 plus var2. So now guys, see, I have not inserted an extra space here, so that needs to be done in this print statement. So we say var1 plus, and then in quotes we enter a space, and then again concatenate this with var2. This is var and not var1. Correct that, and now we can run our cell. So yeah, as you see here, let's learn Python printed out. Now you probably are aware of substrings. Substrings are a portion of a string. So how do we extract substrings from a string? Well, again, we use indices to do so. Now if you want to extract just a single character, you can just put in one single index, such as 3. So var of 3. I run this code, and that is the single quote here. Now I want to extract, say, from let's, just the word let. How is that done? Well, once again we use indices, but now we need two indices, that is the start location and the end location. The start location is of course 0 because our substring starts from the very beginning of our string var, and t is at the second index location. So in here I could put 2, but then again one thing we must remember is that, so when you're dealing with indices or substrings, the last element or the character at the very last index, that is in this case at index 2, is excluded. So if you want the character at 2 to be included, then your index should be incremented by 1. So in here I'll insert 3, and that will display let, the substring we wanted. Now see, when you're starting from the beginning of a string, it's not compulsory to mention the 0. If I remove the 0 here, just leave the space empty, Python automatically assumes that you want every character from the beginning of the string var. If I run this code again, you'll get the same output. In the similar manner, suppose I want all the characters from the third index up till the end of the string. In that case, instead of putting my last index here, I can just leave this part empty, run the cell, and you'll get the last two indexes. That's basically your third and fourth index elements. Now with strings, you can also find the length of a string just like we did for lists using the len function. So you just say len of var and the number of characters in the string is displayed. So what else can we do with strings? Well, we can use some other functions, some other inbuilt functions with strings here. A few very common ones. One of them is index. So I say var.index and then here I pass the element whose index I want returned. So I want the index for the string et. Yep, not just a single character, but two characters. And that starts at the index location 1. Now here's something pretty cool with Python strings. Now suppose you want to store a string in 3 separate lines or any number of lines, just more than one. How is this done? Well, you'd think that if I just put in double quotes here and say, hey, put an enter, this should work. Let's see whether that works. So there's an end of line while scanning the string literal. So how do we go about this? Is it not possible to store a string in multiple lines? Well, it is, but now we need to utilize something other than just double quotes and single quotes. We'll have 3 quotes. So this could be 3 single quotes or 3 double quotes. I'll show you how this is done. Putting in 3 quotes here. And now that you've put in 3 quotes, you can have your string in multiple lines. So hey, Python is my string. Hey in the first line, Python in the second. And then I'll close this up with 3 quotes again. Now let's try running the cell. So yeah, that works. That is how you store a string in multiple lines. Now when it comes to printing strings, often you require it to be printed in certain format. Now as we saw previously here, when we have 2 variables each storing a separate string and we are concatenating them, we just use the plus sign to concatenate them with other string literals in between. Now since this just utilizes 2 strings and it's a pretty short print statement, looks fine. But what if you had like 3-4 variables which need to be put into the string altogether? If we use the plus sign again and again, keep breaking a sentence, closing and opening string literals, putting in variables, it'll look kind of haphazard. So for this, we have the format function. Now I'll show you how the format function is utilized. See, I have a variable name, stores Sam, and another variable place, which stores the string Florida. Now, I have a third variable var, which should comprise of both these strings other than some extra string literals. So basically, it should be hi followed by Sam. So our traditional methods would say this is how it's done. Hi, close the quotes, put in name, variable, and then plus quotes again, open the quotes again, and fill in the rest of your sentence, which is an exclamation mark. So I want it to say, hi Sam, exclamation, welcome to Florida, which is stored in our variable place. So that is the traditional way we would do it. If I print this out, just have a space in here, run it again. So yeah, this works fine. But as you see, this looks kind of messy. We are closing and opening these quotes again and again. So the simpler and the neater way of doing this, we use the format function. So you say var equal to hi, and instead of closing the quotes now, just put in these brackets here and then the exclamation. Now these brackets are basically placeholders. So that's where our value for the variables will appear. And then we fill in the rest of the string, welcome to, brackets again, and that would be the placeholder for our variable place. Now once this skeleton of our string is done, we say dot format, and now as parameters to the format function, we will pass the 2 variables which should be taking the place of these brackets. Now we'll do it in the same order, name, comma, place. So name will come here and place will take up this spot. Print var out now, and yeah, so that's done. Our string is printed. Now it's not necessary that you need to have them in the same order. What I mean is it's not necessary that you need to put your variables in the same order for the format function. I could have place first and then followed by name. Now all you need to do is that this bracket here should be the placeholder for your second argument. Now the first argument is considered at the 0th position, the second argument at the first position. So over here I'll just put in 1. So that would be the placeholder for name, and over here I'll have 0 placeholder for our variable place. Now run this code once again, and as you can see here, the very same output. So now we have covered the very basics of strings. Let's move on to our next data type, which is dictionaries. So let's begin with understanding what dictionaries are. Well, dictionaries are sort of like lists, as in you have multiple objects stored in it. But in this particular case, we have a pair, or we can say every object is a pair of a key and a value. So how exactly that works? Well, I'll write down the first dictionary here, and then we can better understand what exactly this is. So let me create a dictionary of months. So here in this dictionary for months, we'll be storing the keys as every month name, and the value for each of these keys will be the number of days in that particular month. So my first month is January, and January has 31 days. So this is how you enter it, guys. The first value here is the key, and this is the value for this particular key. Now this key can be an integer, it can be a string or any other data type, and as of the value, the same case, it can be any data type. So now I have January, comma, followed by your second key, which is February, and then the value for this key, which is 28, since February has 28 days in a non-leap year, but that's just how we'll consider it. Followed by March, April, and so on. So I'll just paste the values in here. So as you can see here, guys, we have the month names as the keys, the number of days in the month as the value for each key, right up till December. So that is what a dictionary is. And in a dictionary, well, these things are ordered, as in later on the order does not change. It's very specific as to how you enter, just like lists and tuples. Now what could be the requirement of doing this? To better understand dictionaries, let's write a program where we'll be using this dictionary we just created. So we'll take an input from the user, which is basically the number of days that has passed since 1st January. So suppose the user enters 45. What we need to output is which is the 45th day of the year. So the 45th day of the year is basically the 14th of February. So that's how we got to go about this. Let's begin coding. First, we'll take the input from the user, and I'm putting the int function first itself because the input should be an integer, but we'll receive it as a string. Enter the day of the year. Now we'll have a for loop to iterate through this dictionary. So guys, I showed you before how you can use a for loop to iterate through a list. It's just similar with every sequence in Python. A for loop can iterate through a list, a tuple, a string, and even dictionaries. So for I in months, so what we'll do here is we'll have a variable, say count, and to this variable count, we'll keep adding the number of days in the month that's passed. So if I say I, actually it points to this pair or the key, and if I say months of I, this will give me the value of that particular key. So count plus months of I. So I'll keep adding the number of days in the month to count till count is actually less than the input given by the user. If count plus months I is greater than n, which is given by the user, in that case, what we do is we break out of this for loop. And if that is not the case, then we will continue adding months I to count. So outside this for loop here, we need to initialize our count variable to 0. So let me explain this for loop once again before we move ahead with this program. Basically, the user will enter a day of the year. That is the number of days that's passed since 1st Jan. Now, based on that number, what we need to return to the user is the particular day of the month that this number corresponds to. So for that, we take the input, store it in n, then we iterate over our dictionary months. Now every time that we iterate over this dictionary, that is for every iteration, we'll first check if what count holds so far plus the number of days in the particular month that we are iterating on currently is greater than n. So if this number is greater than n, means that we already surpassed the day that we were supposed to output. And in that case, we need to break out. So if count plus months of I is greater than n, that means that if we continue adding months of I to count, we'll be surpassing the day that we need to output. So we will break out of the for loop, and outside the for loop, we'll continue processing this. Now, as long as this is not true, we can continue adding the number of days in that particular month to count. For example, so the user enters 45. The first time count is 0. You come in here and 0 plus months of I. So I is on the first iteration, that is January. So you'll have count plus 31, that's 0 plus 31. And we'll check if 31 is greater than n, which is 45. So of course 31 is not greater than 45. So we come to this statement here, and so count will be incremented to 31. Now the for loop moves on to the second iteration. This time I points to February. So if you do 31 plus 28, that will be 59. 59 is obviously greater than 45. So we'll break out of this for loop. And what is next? Because although we broke out of the for loop, we have not yet reached 45. So out here, we will print out the day and we'll say it's the, and I'll be using the format function here. So I have a placeholder which will display the value as to which day of the year it is. It is the date of followed by the month. Now out here, dot format. Now it's pretty obvious that this placeholder will be taken by the month, which will be I. But what about this placeholder which should hold the date? Well, to find that out, we just need to do n minus count. So n is the total number of days that we had to go through, and count is the number of days that we actually went through and broke out of the for loop. So the difference between these two values will give you the date for that particular month. Now, another problem that we'll be facing here is using the variable I. Since I was created only in the for loop, its scope ended with the for loop. So to keep the I variable alive, let's give this a global access. So I'll declare I outside the for loop, and now you can use I in here. So let's run this program. Enter the day of the year. Well, months is not defined. We did not run this function here. So with dictionaries or anything in Python, actually the syntax is pretty important. Made a few syntax mistakes here. Quickly correct that. Let's run our code once again. So our months dictionary is created. Now we can run our program which utilizes the months dictionary, and it's working fine. It says it's the 14th of February, which is right. So I hope you understood dictionaries and how it can be utilized. So before we move ahead, we look at a few functions that's used with numbers. Now a lot of these functions are provided under the math library. So this is the first library that we'll be exploring in Python today. And it's actually a pretty straightforward library, and we'll just look at some of the functions that's most commonly used in here, because it has a large number of functions and it's not possible for us to go through everything. Now along with that, we'll also look at a few functions which is not specifically in the math library, but then they are built-in functions used with numbers. So let's start. Now my first variable will store an integer 5, and I want to print out the square of this number. So within quotes, I'll have the string a to the power 2, and out here, so previously we saw that we can just use double asterisk symbol to show power, but we have a function which does this much more neatly, which is POW, short for power. Now to this function, you just pass your variable which stores the integer and the power to which you want it traced. So this way you can do it to the power 2, 3, 5, 10, anything. So I'll run this code, missed out a comma there. And as you see here, a to the power 2 is 25, which is returned by our function pow. Now let's import our math library. So this is how you import libraries in Python. Just use the import keyword followed by the name of the library. Now my first function from the math library would be to find the square root of a number. So I have square root here, say math.sqrt, pass the variable which stores the integer to this. And there you go, that's the root of 5. you also have the ceil function, which basically returns the smallest integer that's greater than or equal to the number that you pass to this function. Just copy paste the statement in here, ceiling, and the function's called ceil, as in C-E-I-L. And to this, since a holds an integer, math.ceil will not really make sense with this particular variable. So I'll just put in some value, 6.78. Now let's run this code and it returns 7. That's because 7 is the closest or the smallest integer that is greater than or equal to 6.78. Similar manner, you could also use the flow function, which again comes with this math library or the math module, and that will give you 6. So the math.flow function returns the smallest integer that is less than or equal to the float or the number that's passed to this function. Now, like you have the modulus operator, the math module also has a function which does the exact same thing, and that's called fmod. So to this, you pass two numbers, the divisor and the dividend. Say 6, 5. This should return the remainder of the division. So basically 6 is divided by 5 and the remainder of this is what fmod returns, which is 1. So 6 by 5 returns 1. So you can explore more functions within the math module. These are just some common ones and we quickly had a look at them. We'll now move on to the next topic. So while learning lists, we looked into what for loops are and how they work, how you can use them to iterate over a sequence. Now there's another form of loops, which is the while loop. Now while for loop is mainly used to iterate over a sequence, while loop is used to perform a block of operations repeatedly an unknown number of times. So here we learn while loop and I'll show you the syntax, and we'll learn while loop through a program so you better understand its utility. So we'll write a program to find out if a number entered by the user is an Armstrong number or not. So first of all, for all those who don't know what an Armstrong number is, the Armstrong number is any number that is equal to the sum of its digits raised to the power of the number of digits in the number. So I will show you an example. If you say the number 10, to find if 10 is an Armstrong number, you gotta basically do 1, that is the first digit of the number 10, raised to the number of digits in 10. So that's 2 plus the second digit in number 10 raised to the number of digits in 10, which is 2. So now this is equal to 1, which is not equal to 10. Therefore, 10 is not an Armstrong number. Now, if I take the number 153, to find if this is equal to an Armstrong number, you say 1 to the power of 3 plus 5 to the power of 3 plus 3 to the power of 3. And now these digits actually do add up to 153, which classifies 153 as an Armstrong number. So now that you know what an Armstrong number is, we can begin typing in the code for it. The first thing we have to do is we'll take the input from the user. I'll store it in a variable n, and this input needs to be converted to integer. Now we have to raise every digit to a power equal to the length of the number. Therefore, we need to find the length of the number. Now let's do that. So I'll store the length of the number in L. Now, of course, there's a way of finding the length for an integer through a loop, but it's much simpler if we convert this number back to a string and then use the len function on the string to find its length. So use the len function on the string form of n. So basically what we are doing here, I'll explain it once again. N is an integer. We are converting that to a string and then we are using the len function on it, because you cannot directly use the len function on a number. So now L stores the number of digits in our integer n. Okay, so before we move ahead, let's figure out our logic. So basically we have to extract each digit from a number n, and this can be easily done through the mod operator. So if I do n mod 10, the last digit of n is extracted. Now if I want to extract the second last digit of n, I can just divide n by 10. So suppose n was a 3-digit number. Once you divide it by 10, it becomes the 2-digit number. So now you have the first 2 digits of your number in n. Again, if you do the modulus operator on this, that is you do mod 10, you can extract the second digit of n. So using this logic, we can extract each digit of n, and as in when we do this, we will simultaneously raise the digit to the power of L, which is the length of our number. And then we will keep adding this number that we received to another variable, say sum. And at the end of our while loop, that is once all these digits have been extracted and raised to the power of L and added to sum, we will compare if sum is equal to n. And if this is so, then of course our number is an Armstrong number. So let's begin. Now, as I mentioned previously, since we are going to be modifying n, it's better that we store it in another variable before proceeding with our loop. So I'm creating this other variable num here, which will hold the value of n. Now here's my while loop, and this is how you write it. So you have the keyword while space followed by the condition to be met. Now I want to run this while loop till num actually exists. What I mean is once you have extracted the last digit of num is empty. Then you can exit out of the while loop. Until then, we'll continue repeating the instructions within this block. Now, the first thing you do is you extract the last digit from num. So I'll store this in the variable rem as in remainder. So you say num mod 10 and we'll get the last digit of num. Now we will reduce num to 2 digits, so that the next time we do num mod 10, be able to extract the second last digit of num. So num equal to num by 10. Now guys, here we would be using double slash preferably, because single slash returns a float value, double slash always returns a whole value, an integer, which is exactly what we want. And now we will have a variable sum. Let me just quickly declare this outside our loop. Now sum will be equal to sum plus the remainder raised to the power of L. So as you guys saw previously, we can use the power function for this. Now these three statements must be repeated in the while loop until num holds nothing anymore. And once that's done, outside here, we'll have an if statement where we'll check if sum is equal to n, which is the number entered by the user. If that is so, we'll print out this is an Armstrong number. Else, print out this is not an Armstrong number. Armstrong with the capital A. And yeah, so that's our code. Let's run this code, enter a number. I'll be entering 10 first. And it says 10 is not an Armstrong number. Enter 153, which is ideally an Armstrong number. So let's see if that's what our program says. Well, yeah, it does rightly say that 153 is an Armstrong number. So program's working fine, and I hope you understood how the while loop is used. Now let's move on to our next topic, which is functions. So what are functions? Well, functions are these blocks of code which can be called from anywhere in your program. So why do these blocks of code exist? Why can't we just write our entire code in a complete flow? See, often when you write a program, there are a number of operations being performed. Now, if you put in every operation one after the other, a program looks kind of clustered. It won't make much sense and it won't be organized. Well, this is one of the reasons why we use functions. With functions, you can actually separate out the different operations that are to be performed. For example, if you're writing a program which will be performing addition, subtraction, multiplication, division, all of these, you can have a separate function for doing each of these operations. So that way, the minute a person looks at your program, they are able to understand better what is happening, and it's not just lines of code that are just everywhere. Now, the other advantage of using functions is, as I mentioned before, they can be called from anywhere in the program, and this makes them reusable. So if you have a set of instructions which are to be repeated sometime in the beginning of a program, sometime in the middle of the program, and then again in the end of the program, instead of having to write this code again and again, what we can do is we can just have a function which holds all these lines of instruction, and whenever necessary, wherever necessary, you just make a call to this function. So now that we understood kind of what functions are, let's write a very simple program to demonstrate how functions work and basically their syntax. Well, here I'm going to write a program where we'll be adding and subtracting some numbers taken from the user. So here I'll be writing a program where functions will be declared just for addition and subtraction. So let's begin writing our function. Now, for defining a function, you start with the keyword def, a space followed by the function name. So every function has a unique function name. Now, there are cases where functions have the same function name, but that is slightly an advanced topic which we'll not look into right now. For now, we'll ensure that all our functions have a unique function name. So my first function, which is the function that will be taking in few numbers and finding the difference between them, will be called subtract. And now functions are always followed by these curly brackets. It is not compulsory to put anything within the curly brackets, but in this particular case, we will be putting something inside. Okay, so before I proceed, let me give you a few terminologies. Now, whatever you put inside these brackets, they are called parameters or arguments to the function. So function which does not accept any parameters are called non-parameterized functions, and functions that do accept parameters are called parameterized functions. So for now, this is a non-parameterized function. Now function name, just like any other block in Python, is followed by the colon, and the very next line with your indentation, you enter your code. That is the operation that this function is meant to perform. So this function will be finding the difference between the two numbers, let's say 20 and 10. So the difference between 20 and 10 will be stored in diff, and then what you got to do is you need to return this value. But where are we returning this variable to? Well, that is the next part of our code. Whenever you define a function, it's of no use whatsoever unless you make a call to this function. So a call to this function is basically like your program saying, hey, I need to use this function right now. So whatever's in your body, perform that operation and give me back some value. Of course, once again, this return statement is completely optional in functions. You can just print out the value that's stored in your variable diff right here. But just to show you how this works, we'll be returning this value. And technically, you should always be returning values from a function rather than printing it out, unless the very purpose of the function is to print out something. So now let's make a call to the function. Enter the function name, of course, followed by the bracket. Always have brackets for your functions. And that is it. That makes a call to your function. But see, here we are actually returning a value from this function. So where does this value get stored? Well, the value is returned back to the call statement. So while you're making your call, you also need a variable here which will store the returned value from the function that you're calling. So result here will store the value diff once it's returned. So that is how this works. If I run this code now what I need to do is, obviously once I have the result, I should print it out. Now let's run this code. And as you can see here, its result holds the value 10, which has been returned. So let me explain the flow of this program once again. Now always the statements that are executed are not the functions, but the statements just below or above the functions. So the functions are your second priority. Any other statement is always executed before it. And the function will only be executed when a call is made to the function. So your execution starts here in this particular case, which is a call to this function subtract. So then the control passes to subtract, performs this operation and returns this value diff. Now this value is always returned to the very same line that the call for the function is made from, which is this line number 5. And we have this variable result here, which is all ready to hold this value or store the value returned by the function, that is diff. So now result holds a value 10 and then we print it out. Now the next step is we'll convert this function to a parameterized function. So what I'll do here is we'll have the values 10 and 20 inserted in these brackets. So that means we are passing these values to this function. And if values are being passed to a function, the function should also be able to capture those values. So over here, we'll have two variables because we have two values passed to it, A and B. So that A will store the value 10 and B will store the value 20. Now, B holds the value 20, which is the greater number. So we say B minus A and then we return diff here. Again, diff will be captured in result and the rest of the process exactly the same. So let's run our code again. So the result's the same, but as you can see here, we slightly modified our function. So that is parameterized and non-parameterized. Now there are situations where you actually aren't sure about the number of parameters that will be passed to your function. So this could vary from execution to execution. Can this also be handled in Python? Yes, definitely. This can also be handled handle in Python, and that is what we look at next. So our next function that we'll be adding to this very program is a function to find the sum of numbers. So I have a function here, def find sum, and in here we need to find out a way to somehow allow this function to accept any number or varying number of arguments. So for doing this, we have a keyword which is args, and args is always followed by a single asterisk. So basically this is like saying it's a list, and any number of arguments that you pass, it's stored in a list format in args, and then you can extract them one by one from it using a for loop. So now that you have args here, what we can do is have a for loop for I in args, and you have a variable sum, or since sum is a keyword, I'll say add equal to add plus I, and then out here I can return add, and of course before entering the for loop I also need to once define add, assign it to 0. So what's happening here is, guys, no matter how many arguments you pass here, args is like this list which holds the arguments. Using the for loop, I will iterate over every element stored in args, and it'll be added to this variable add, and then finally we'll be returning add. Now we can make a call to this. Again, since this function returns a value, we need to have a variable here which is ready to accept the value. That'll be result 2. Then I say find sum, and pass numbers to it. So I'll be passing 10 and 20 here, and then print out result 2. Now in the very next line, I'll have another result, make a call to the same function, this time passing 3 arguments. So let's see this works. And as you can see here, guys, it did work. Our function find sum is able to accept any number of arguments. Now there's one more keyword which is kwargs. Okay, so we'll be modifying our function find sum. Now what is kwargs? See, often you're just passing any number of arguments, but sometimes you need to pass these arguments along with some labels or say keys. So you're saying A is equal to 10, B is equal to 20, C is equal to 30. Now I want my function to capture these values as it is. The first parameter 10 should be stored in A, 20 in B, 30 in C, and so on. So here we are associating values with some keys. So in that case, we will be using this kwargs keyword here, and how this changes our code is now it's not just 10 and 20, but we can say A equal to 10, B equal to 20. So you see this kind of a pair can be passed. Over here too, we can have A equal to 10, B equal to 20, C equal to 30. So now here, we will be changing this args to kwargs because that's what we'll be accessing. And when we say dot items, so you got to say kwargs dot items to receive each pair of values, that's like A, 10, B, 20. So basically kwargs dot items returns a tuple. Now you want the second element of the tuple because as I mentioned previously, the tuple contains A, 10. So 10, which is the second element, is what you want. So in here, when I points to a tuple, you'll extract the second element of that tuple, which is at index location 1 obviously, and add it to this variable add. Now let's run this code here. And as you can see here, guys, it's worked out just right. So the difference is 10, and then our second call to find sum returns 30. Our third call returns 60. Now the next thing we look at is nested functions. So just like nested loops, nested functions are functions within functions. So let's begin. Create a function func1 here, and in here I'll have a print statement. Just prints out this is the first function. Now inside this function, I'll create my second function, which will be called nested func, and the nested func will print out this is the nested function. Now what we'll do is we'll create another function out here. So these two functions in here that forms the nested function. We'll create a third function, an outer function which I'll name outer func. And this will print out this is the outer function. So now if we make a call to func1, that will not really execute the nested function because only the definition of this function is nested. There's no call to the nested function specifically. So what we can do here is we'll add a return statement, and the return statement will basically make a call to the nested function and then return the control to the calling statement for func1. So func1 call statement is here. Now see, although we have the return statement here, I'm not having a variable here because this return statement does not really return back a value. It just makes a call to this nested function, and the nested function too has nothing to return back, just prints out a statement. So now let me run this code, and as you can see here guys, once we made a call to func1, the statement within func1 was executed, which is this is the first function, and then this part was skipped. We went to the next statement within func1, which is the return statement that makes a call to the nested function. So this not only makes a return call, but it also makes a call to the nested function. The nested function gets executed, which prints out the statement here, and then the control is transferred back to the line that makes your main call. So that is how nested functions work. Now you must be wondering why I created this outer function here. I'll tell you why. So with Python, functions are also objects. So basically you can pass a function like you pass an object to a function. So here to func1, I'll pass outer func as an object, and here I'll be accepting this function which is passed as an object, and then within the nested function I'll use this parameter which is passed to func1 to make a call to this outer function. So if I say called func, which is basically the function name, and then just add the parenthesis to it, it'll make an automatic call to this function here. Okay, so now let's run the code. Well, I just deleted this bracket by mistake. Put that back in there, close the quotes, run our code once again, and yeah, so all our three functions have been executed. So I'll once again explain what we did here. I made a call to func1, passing this function as an object to it. Now this function accepted this object in this variable called func, and it first printed out the statement in func1, came here to the return statement, which made a call to the nested function. The nested function printed out this is the nested function, and then it made a call to outer function, and then outer function printed out this is the outer function. So this kind of passing of functions as objects is also possible, and that was a modification with functions we saw, which may not come in very handy, especially as a beginner, but it's good to know this is a capability that Python provides. Now the next thing we look into after functions is of course classes. So as you probably already know, Python is an object-oriented programming language. What this means that all the functions and data are actually tied up around an object. So using functions and the data, you're describing an object. So that really becomes a link between a programming paradigm and the real world situations. For example, over here, we will be creating a class called person. So when I do this, what I'm saying is that I'm going to define a person here, or I'm going to create a blueprint of a person here, providing the basic functionalities of a person and providing some data which is always associated with a person. Now the actual data will obviously vary from person to person, but what they are essentially will be the same. For example, a person will have a name. Every person has a name. Now the value of the name or what the name actually is, that could vary from person to person, but again it is essential that a person will have a name. So let's start coding here, and through the code I will explain to you how classes work. Now classes tie up everything, that is they tie up the functions and the attributes of an object. So class person, so that is exactly what our class person does. Now in here first we'll start defining the functions. Now what are the functions of a person, or what are the methods or operations of a person? Well, a person can talk. So we'll create a function here. It's called talk. So def talk, and in our function we'll just print out hi, I am say Sam. Now our second function will be vote, because again people vote. So in here now our second function would be vote, because people can vote. Now minorities cannot vote, so we'll have an if statement in here which will check if age is greater than or equal to 18, the person can vote. So we'll print out I am eligible to vote, else I am not eligible to vote. Now you must be wondering what this age is. Well, age is an attribute which I will explain to you later. For now, I'll just put in the value age here, and it's still actually not complete. We'll complete it in a while. So those are our two functions or our two methods associated with a person. Now see, we want to be more specific. We cannot say that these two functions are just absolutely general, because every person is not Sam. Every person is not eligible to vote, or every person is not eligible to vote. So here, what we'll do next is we'll create an object. So when we create an object, we are basically creating an entity of a person. So our first object could actually represent Sam, and whether Sam is eligible to vote or not, that is Sam's age. Another object that we create could represent someone else. For example, someone named Richard. So our second object that we create could represent another entity, say a person named Tina. So that is how objects work, and that's the very purpose of objects in a class. So let's begin creating our object. So you say obj1, our first object, and an object is of the class type. So we say person, and now within person, we need to pass the values for this object. So if object is representing a person, we need to pass the name of the person, the age of the person, and in this particular case, in fact, I'll even pass the gender of the person. So my first person's name would be Sam, gender is male, and age is 22. Now, does putting the values like this mean anything? Well, of course not, because we have not created any attributes yet. So what are attributes? Well, I'll explain that to you through another concept which is called constructors. So constructors are also functions. They are a special type of function, and in Python they are called init method, and this is how you do it. You have double underscores and then you write init and then double underscores again. So it's a method, and now init method in this particular case will be parameterized. So guys, basically this line here is a call to this init method, our constructor. So here we need to accept the values which are passed to this. Now the first value which is passed to it is name, the second value is gender, and the third value is age. Now, as we are going through the init method and better understanding objects, let's understand another keyword, self. So what is self? Self basically is a reference to the object that is making a call to a function. So if you have programmed before, like in Java or something, self is like this, the keyword this, which is a pointer to an object. Self is the same, but in Python, you always pass self when you're dealing with objects. So here you mentioned self within the constructor, and the reason self is not passed to the constructor is because it's actually passed but not exclusively. So this object, when you're making a call to the constructor, the object that you're creating using that call, that is what self refers to. So here self refers to obj. Now down here, we will assign values to our attributes. Now these are actually just values that we are accepting from here. They are not our official attributes. In this particular case, my official attributes have the same name because that would make things simpler, and well, a name would still be called name. So you say self.name and assign the value name that you received from the call to the constructor here, followed by self.gender equal to gender, self.age equal to age. So let me explain what's happening here once again. We have class person, which is basically the blueprint of a person. Now this blueprint is not specific to a person, it's just in general. So the functions that we define here could apply to any person. But then the attributes will be specific to a person. The attributes being name, gender, age. All people don't have the same name, gender, and age. So for that purpose, we'll be creating objects which are called instances of a class, and each object is associated with its own values for the attributes. And to assign those values, that is why we have the init or the constructor here. So we'll make a call to this constructor. So to make a call to a constructor, you're not actually putting the constructor name, we are just making a call to the class. So that is the syntax, not just in Python, but any programming language which is object oriented. And in the call, we pass the values for the attributes. Over here, here, referring to the object that is making this call, which is self, we'll assign these values to our attributes. So these three attributes, gender, name, gender, and age, are common with all the objects that we create, but the value of these attributes will change from time to time. So here we just created our first object, which is obj1. Now my second object, obj2, will be a woman. So her name will be Tina, gender female, and age is 16. So now we have both our objects here. What we do next is, once our objects are created, the attributes have values assigned to them, we can call the functions. Okay, so for that, before we do that, actually, come back to your function def talk. Now here we initially just said print, hi, I am Sam. But see, the first person's name is Sam. The second person's name is not Sam. It's Tina. So we need to be able to change this. So what we do here is we'll make this kind of dynamic where we'll not be entering the name in the code. We'll just give in the variable name. So I'll say self dot name. So hi, I am, and the name that follows will be the name attribute associated with the object that makes a call to this function talk. So now you're like, an object makes a call to this function? Well, yes, when we are dealing with classes and we have the functions and the attributes associated or tied up around an object, we need to be specific about which object is making a call to the function. So for that, if I say obj1 dot talk, then we are basically making a call to this function talk using the object obj1. And so in the parameters here, we'll accept self, and self will be pointing to the object that's making the call, which is obj1. So over here, when I say self dot name, it prints out the name of obj1, which is Sam. And similarly, if I make a call to talk using obj2, the self will then refer to object 2, and self.name would print out Tina. Now, in the same way, vote also will be accepting an object, and we'll make a call to vote using an object. So obj1.vote, obj2.vote. Okay, so I hope that was clear. Now we can run our program. Okay, so what went wrong here, guys? There's an error. If you check out the error, it says name age is not defined. But we did have the attribute age defined here. See, if you come back to your vote function, you'll notice we missed out self. When you're seeing just an attribute age, it has no meaning. The age attribute does not exist without an object. So here, once again, we need to say self.age. And let's run our code now. So we have our output here. The first time we made a call with obj1 to the talk function, and it printed out, hi, I'm Sam. We then made a call to the vote function, which said I'm eligible to vote, because as you can see here, Sam is 22 years old. Then we made a call to talk using obj2, and it said, hi, I am Tina. And we then made a call to vote using obj2, which said I'm not eligible to vote because Tina is under 18. So with that, we have covered all the very basic topics of Python. Next, what we'll be moving into are the libraries which are used with Python. Of course, if you know anything about Python, there are a large number of libraries used with Python. But today here, we'll just concentrate on the few of the most important and popular ones. So first one's gonna be the Numpy package. So the Numpy package is basically an array processing package. It provides you the facility or the capability to build n-dimensional arrays. So the n can be any number. Basically, you can have a single dimensional, 2 dimensions, even 10 dimensions, although that's never used. But yes, it provides you the capability of doing that, along with which it provides you a few functions and makes it easier to deal with these arrays. So let's begin. We'll be looking at the very basics of Numpy today. So the first thing you need to do is you have to import Numpy. So you say import Numpy, and so that we don't actually have to type the entire word Numpy every time we are using a function from the Numpy package, we will shorten this or use it as NP. So let's start off with creating an array, a Numpy array. Now my array name would be arr1, and to create an array, you say np.array. And now to this, we will pass the elements of the array in the form of lists. So you have your bracket inside which you will pass the elements of the array, and that will be in the form of a list. So you always have these square brackets. Guys, do not forget these square brackets. They are very important in the syntax of creating a NumPy array. Now, within this, we can start inserting our elements. Okay, so let's begin with creating a single dimensional array in NumPy. So just put in your elements 1, 2, 3, 4, 5 separated by commas, just as you would for a list, and that would be your first NumPy array. Now we'll print this out, run our code, and here you go. So that is your first array. Now let's look at how you can create a two-dimensional array. So again, the elements passed to the function array would be a list. So if you want to create a two-dimensional array, basically you're going to create a list of lists. So my first element of this array would basically be the first row of my array. That would be 1, 2, 3. And then comma, and then input the second row of your array. So that's 4, 5, 6. This would be array 2. Let's run this code now. So that's our two-dimensional array, guys. We have the elements 1, 2, 3 in the first row, 4, 5, 6 in the second row. Now, arrays can be formed directly from lists. That is, you can actually create a list which contains these elements and then just add the name of the list to the function array. So for that, let's see how it's done. Creating my first list, L1, which will hold the elements A, B and C, and then my second list L2 will hold the elements D, E and F. So now we have both our lists. Let's use these lists to create our third NumPy array. You say np.array just as before, and this time your elements which will be passed to the array function are L1, L2. So as you can see here, this formatting is much neater, but obviously it does not make sense to often do this because you're utilizing like double the amount of space. You're actually creating two lists first and then putting these lists in, whereas these lists will never come in handy again. So I'm just showing you for the purpose of knowing that this can be done. It's not probably the ideal method of doing it though. Let's print out R3. So yeah, that's our array 3. So now that we saw how you can create arrays in NumPy, let's look at how you can access these arrays. So again, with arrays too, just like any other sequencing, we will be using indexing. So just like we saw with lists and all the other sequences, arrays also have indices, and that's exactly what we'll be using to access the elements of an array. Okay, so let's go back to the second array we created, which is array 2. I'll just print that out here. Okay, so those are the elements of array 2. Now I want to extract the elements of the first row of my array, skipping every alternate element. So let's see how that is done. First of all, enter your array name, and within square braces, the indices go in. Now, how do these indexes go in? Okay, so the first thing you have to mention is the rows. So for that, if I say 0:1, that means that all the rows from 0 to 1, excluding 1, will be printed out or will be extracted from array 2. Now, obviously 0 to 1 excluding 1 is just 0. Suppose our array had 5 rows and we want to extract 4 of them, then we would say 0 to 5. So that would be extracting all the rows from the 0th row up till the 4th row, because always the last index is excluded. Now that is just the rows part. So in this particular case, we want to extract only our first row. So we say 0 to 1. Now the second part is where we need to specify our columns. So again, the format for specifying the columns is just like that for rows. If suppose our array had 5 columns and we want to extract the columns 3 and 4, we would say 3 to 5. So since 5 would be excluded, column number 3 would be taken, column number 4 would be taken. But in our particular case, we want to extract all the columns. So we just say 0, 2, although 2 does not exist, that means that it will take all the columns from 0 to 1. That will be our 2 columns. Okay, and then following this, here's something new. So in fact, just like lists, it's not that new. Once you put your colons here, you can specify a number which will dictate a pattern of skipping elements. So what I mean is, if you want to skip every second element, you can just say 2 here. If you want to skip every third element, say 3. And when I'm saying skipping elements, I mean column wise, not row wise. So if I say skip every second element, it would print out 1 and then 3. Then that's the first row. Now in the second row, it would print out 4 and 6. So you see the second elements, which are 2 and 5, are skipped. Now even to print it in reverse, you can just say -1. So then you would have the elements printed as 3, 2, 1, 6, 5, 4. Okay, so that is how the indexing for arrays work. Now once again, just like in lists, if you're taking all the rows or columns right from the beginning, you do not have to put 0. You can just skip that part. It's automatically assumed to be so. And once again, if you're taking all the rows or columns right till the end, you can also skip the end index. Now here we'll still keep 1 because we only want the first row to appear. So if we do delete 1 here, that means the first and the second row will appear. And we want to skip every second element. So enter 2 here, run this. And yeah, so we received 1 and 3. So basically how this works, I will explain it once again. You're saying you want all the rows from 0th to 1st. So 0th row is extracted, but because the end index is always ignored, the first row is not extracted. And in similar manner, when you go to your column section, you're saying you want to extract all your columns. So that's 0th column up till the second column, or the first to the third column. So since you're extracting all your columns, from the first row, you'll be extracting the numbers 1, 2, 3. Now again in this, you're saying you want to skip every second number. And finally, all you're extracting is 1 and 3. Now here's another great advantage with NumPy arrays. One of the main reasons actually that we use NumPy arrays is not only does it let us create very powerful arrays, it also provides us with functionalities which makes dealing with these arrays very simple. For example, if you would have created a normal array and you wanted to increment every element of the array by 1, you would actually have to create a for loop, iterate through every element of the array and manually add 1 to it. But in the case of NumPy arrays, it's much more simple. So if I'm going to add 1 to every element of my array ARR2, I can simply do ARR2 plus 1. And yeah, as you see, every element has been incremented to 1. Very simple, isn't it? Similarly, you can perform other operations on it too. For example, I'll be multiplying every element in my array 2 with the number 2, and yep, that's your result. And again, you can also easily find the transpose of the array by just invoking it with capital T. Okay, let's run this. So that's the transpose of your array 2. Now there are a lot more functions which you can definitely explore. It's out there on the internet. A lot more you can do with NumPy arrays. For now, we are just covering the basics of it. And now we'll be moving on to our next package in Python, which is Pandas. So Pandas are one of the most popular packages used for data analysis. It provides you a way to store your data in a structured format. Now Pandas provide 2 such structured format. The first one is series, which allows you to store data in a one-dimensional form, and then you have data frames, which is sort of like tables. Now the thing with Pandas is it does not just allow you to store this data, but again, like NumPy, it gives you a lot of functions to work around with this data and analyze this data. Now, in fact, Pandas also provides you methods to plot graphs using these data that you have stored in your data frame or series. So we'll be looking again at the very basics of Pandas today. Just like any other package, before you start using it, you need to import Pandas, and we'll be importing this as PD. Now, as I mentioned before, it has 2 forms of structured data. The first one is series, which is what we'll be looking at right now. So series are one-dimensional data storage. Let's say I have a variable data, and to create a series, we will first create a list, say 1, 2, 3, 4, and then we will use the series function from Pandas, that's pd.series, And to this, we'll pass our list. This function will basically return back your series, which we'll then store in series1, our variable. Now let's print this out. I did not run my first line here, which is importing pandas. So that is our series. As you can see here, guys, all our elements are lined up one below the other on the right side. And these numbers that you see on the left side are basically the indices. So by default, the indices are integers from 0 up till the number of elements present -1, and the type of the value stored in our series is int64. Now again, of course, we are completely allowed to change this indices value. So let's see how that's done. Create a list again named index, to which I'll add these characters A, B, C, D, and E. I'll have my second series 2, which will be equal to pd.series. And to this, I can pass first the elements that I require in my array. Since I have just 4 elements, I just need 4 indices. Now to my series function, first I'll pass the list of the elements, followed by the list of the indices. And that is how you can assign your very own indices. Run the cell, and here you go. So now the indices have changed to whatever you specified. Now another way of specifying the indices is through passing a dictionary to your function series. So let's look at how that's done. I have my third series here, series 3, pd.series. And now since I'm passing dictionaries, have curly braces. And now we can pass our index and the value associated with the index, second index, value associated with this, and so on. It's not 1, this would be 3, and that's it. So that's our series 3. It's essentially the same series as before, just done in a different way. So there you go. That's creating a series using a dictionary. So we just looked at 3 ways you can create series. Now, of course, there are other ways, like you can also pass an array to a series. Let's move on to data frames next. So unlike series, data frames actually provides you a table-like format. So here you even have column names. So how is that done? Well, first, once again, we'll begin by creating a list. In fact, I'll have 2 columns in this particular data frame, and we'll have a list of values for each of these columns. Now to create my data frame, first I can just create a dictionary. So I'll say first, which will be the name of my first column, and the values that'll come under this first column would be list 1. Similarly, I'll give the name for my second column and then the values that fall under the second column, which is list 2. Now I can finally put this all together to form my data frame. So you say pd.dataFrame. That's the function for creating the data frame. And I'll just pass my dictionary data to this. Store this in my variable df, and let's run this cell. Okay, so looks like our data frame is created. Let's now print this out. And that is what a data frame looks like, guys. So you have your indices here once again, and you have columns and rows. So it's basically a table-like format. Now data frames comes very handy. In fact, it's one of the most used structures when you're actually using Python for a project, because the kind of data we receive these days, it's huge amount of data and it's always in the table-like format. So this is how you can actually view it, and you can perform operations or analyze the data with much ease using the functions provided by Pandas and other libraries. So that is it for Pandas. Let's move on to our third library, which will be Matplotlib. So the Matplotlib package in Python is used mainly for plotting graphs, and with just 2 or 3 lines of code, you have a neat graph plotted. So here today, we'll be just exploring some of the very basic graphs which are often used. So let's begin. Once again, we need to import Matplotlib, and from Matplotlib, we'll be importing this library pyplot as plt. Pyplot is basically the one that is specific to plotting the graphs that we'll be plotting today. Now for plotting the graph, first of all, you need some data. So first I'll be creating 2 lists, list X, which has 1, 10, 12, 24, and 30, just a few random numbers there. And another list Y, because for plotting most graphs you need at least 2 values. So 10, 20, 30, 40, and 50. Okay, great. So now that we have our data, we can begin plotting. Now the first plot I'll be showing you is the most basic of them all. You just say plt.plot x comma y. So the list x takes up the x-axis and the list y takes up the y-axis. Now in the Jupyter notebook, actually, if you just run this code, this will display your graph. But if you're using any other IDE, you need to go ahead with one more line of code, which is plt.show. Let's run the code now, and there you go. So you see how just 2 lines of coding gave you this nice neat graph here. So all your values in your list X basically takes up the X-axis, and all your values list Y takes up the Y-axis. Now we will look at a few more other graphs which are commonly used. The second one we'll be looking at is the bar graph. So you just say plt bar, again pass X and Y, and plt.show, and that's our bar graph. Matplotlib also provides for a histogram, so I'll show you that too here. You just use the hist function. And of course, histogram, guys, it does not require 2 values. It basically matches up all your elements in one list or one data frame. So it basically is finding out the distribution of the values within a single list or a single object. So you just pass, say, y and plt.show, and that's your histogram. So just histogram does not really make sense in this particular case, because it just shows that these are the values that are present in our y-axis. As you can see, 10 is present, 20, 30, 40, 50. If we had 2 50s, then things would be slightly different. Let's modify our list here once. Let's just copy this y, or let's just create another list here, which is y1. Put in values 10, 20, 30, 40, 50, 50. And then plot a histogram using y1. So there you go. So basically histogram just gives you a measure of the elements which are present, or the measure of the quantity of the elements which are present in your list or your data frame or whatever object you're passing. And finally, we look at the scatter plot. Again, just say plt.scatter, pass x and y, plt.show, and that's your scatter graph. So this basically marks the element, or you could say it basically relates the elements in your list x to your list y. So that is the basic of Matplotlib. There's a lot more you can do with it. You can change the look of the graph, you can change the colors, the font, so much more. But here we'll just explore the basics, and you can go ahead further and experiment with this. Now, the last and the final library or the package that we'll be looking at is the Scikit-Learn package. So what is the Scikit-Learn library? Well, it's one of the most common libraries often used with machine learning. It provides a lot of algorithms. So a lot of your machine learning algorithms or the models are actually already present within Scikit-Learn. So you can just import these models and they are readily available for use. Along with that, Scikit-Learn also provides a lot of inbuilt data sets which you can just import and use for testing and training your model. Now that is exactly what we'll be doing here. We'll be importing one of the already present data sets. So we'll use the random forest algorithm, train the model, test it, and then use a few predictions. So let's begin. So start off with importing your dataset from Scikit-Learn. So you say from Scikit-Learn import datasets, and today we'll be using the iris dataset. Now this is a very common dataset. So it basically predicts a flower, or it categorizes a flower into Centosa, versicolor, and virginica, based on various features such as the sepal length, the sepal width, the petal length, and so on. So we'll have a better look at the dataset, the target, and the feature attributes. Now, once you have imported the datasets library, you just say datasets.load iris and store the dataset into this variable iris. Let's run this line here. So now that we have our data set, let's look at the target variables of this data set. So just say print iris.target names. Now, when you're using the data sets which are already present in Scikit-Learn, it's much simpler to view the target and the feature names because it's already split in such a way. Of course, if you're importing a data set from outside or you're importing an external data set, then you cannot directly say target names. You have to give the column numbers so that the algorithm first understands which exactly is the target and which are the features. But in here, things are much more simplified for us. So as you can see here, guys, these are the target names. All your flowers are categorized as either setosa, versicolor or virginica. Next thing, we look at the feature names. So iris dot feature names. So these are your features based on which the flowers are categorized. There's sepal length, there's sepal width, the petal length and petal width. Now let's look at the actual data. So right now we are just exploring our data set, looking at the various things before we move on to actually building our model. So that's our data. The first one here is sepal length, sepal width, petal length, petal width. So these are your values for the features. Now let's see what exactly are the values for the target. So again, say iris dot target. So that's how your targets are. The zeros basically represent the setosa and ones represent versicolor, 2 represents virginica. So now we are done with exploring our data set. So let's move on to actually processing this, and then we will build our model, train it, test it, and finally predict it. So we start off with assigning all the data, that is all the values of our features, to a variable x and all the target values to a variable y. Now the point of separating these are because when you're training your model, you need to tell the model that these are my features and this is what my target is. Then again, when you are testing the model, you need to provide at first only the features so that it's able, so that you can compare it against your target variables and see how your model is performing. So all this might seem a little confusing right now. You'll better understand as we go through the code. Okay, so now that our data is split into x and y, next we need to actually split this into the train and the test data. So for that, we'll start off by importing the train test split method. Again, this is also present in Scikit-Learn. So that's us importing the train test split. Now let's move on to actually splitting our data. Say train test split. So you pass x and y. Then you need to pass the size of your test data. So this is variable. You can give it whatever size you like, but it's always preferable to keep your test size smaller than your actual training size, because obviously you need much more data to train your model than to test how it's performing. And this ratio is often 70 to 30, or you can say 75 to 25. In here, we'll keep it a 70 to 30 ratio. Give my test size as 0.3. That's pretty much it. Now the thing is, this function returns 4 values. Now the first value that it returns is the portion for training from the x dataset. So you say x underscore train. So this is basically the remaining 0.7% of the data, but only the columns which contain the features. The x test, which is the 30% of the data, but again, just the features. Now we'll move on to the y part. The y is the target variable. So y underscore train, which we'll be using for training our model, and y underscore test, which will be used in the testing phase to see how well our model actually is performing currently. So those are the 4 values that will be returned by the train test split. Just make a small correction here. It's from, not import. So now we are ready to run our code, and looks like we have all the data within our 4 variables since it did not produce an error. So the next step is to build the model. But in our case, thanks to this particular library, we do not actually have to build the model. We only need to import it and then train it. So let's do that. So we'll be using the random forest classifier. First step, import it. Let's now create an object of this. So we say CLF equal to random forest classifier, and now we need to pass an argument which is n estimator. So this is very specific to random forest. N estimator is basically the number of trees that will be created in your forest. So I'm giving 100, so there'll be 100 trees in my particular forest. And now that we have our model, we'll just fit x train and y train to this. And this one line here will train your model. So now let's run these 2 lines of code. So as you can see, guys, that's our model, random forest classifier. And our model is also trained. Now what we do is we will test our model. So to test our model, we'll just pass our features from the x test variable. So xtest basically contains the 30% of the data, but only the features. So 30% of the data minus the target values. So let's provide this data to our model and see if it can predict the corresponding target values. Okay, so to do this, create a variable ypred here, as in the predictions of the values for y, and say clf.predict, pass xtest here. Now let's check out what are these values within ypredict. So these are the values which are predicted by our model based on the input given to the model. So how accurate are they? Well, now how do these match up against the actual values? So all you have to do is print out y test to see how it matches up against the actual values of y. And well, so it seems like everything's all right. Now to be sure, or to see how accurate our model is, we'll import this other library, metrics, and in here we'll say metrics.accuracy score, pass ytest and ypredict. So when you give normalize equal to true, it basically returns a number. If normalize is equal to false, it'll return a fraction. Let's run these two pieces of code now. And well, that is our accuracy, which is actually a very good accuracy. Now in the real world, when you're actually building a model or you're using some external data set, do not expect such a high accuracy the very first time. You'll actually have to tune your model quite a lot to get something this good. But yeah, so that is our basic on Scikit-Learn. So with that, we come to an end to our course on Python. If you have any doubts regarding this, please post them in the comment section below and we'll definitely get back to you. Also, if you found this video helpful, please hit the like button and also subscribe to our channel if you haven't yet. We have a lot more great videos coming up for you. So stay tuned and see you all next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.